Okay, just a video on scientific notation, and this is something a lot of people get confused by, but it's actually not that bad at all. And basically, scientific notation is any number, and they're usually used in really big numbers or really small numbers, but any number, and we can write them as a number between 1 and 10, so some number between 1 and 10, and that's multiplied by 10 to the power of something. And I'll show you what I mean by that. So some number between 1 and 10 multiplied by 10 to the n. Let's talk about this 10 to the n. Let's have a look at what these things. So what's 10 to the power 1? Well, that's equal to 10. What's 10 squared? It's 100. 10 times 10. What's 10 times 10 times 10? That's 1,000. Okay. And 10, 4, etc., etc., etc. And what you just get, you just keep getting zeros and zeros and zeros, and so that just makes sense. Okay, 100,000, etc., etc., just go on forever. Okay. And what happens if you have a number? Let's just say you have 1.23. Okay. Now, if you multiply that by 10, what happens to that decimal place? It moves one spot. If you multiply 1.23 by 10 squared, it moves 2 spots, 10 squared. If you, because it's 100, you multiply by 100, it's 2 zeros. What happens if you multiply 1.23 by 10 cubed, so 3? You're multiplying by 1,000, it's 3 zeros, so it moves 3 spots. So basically, if you multiply any number by 10 to the power whatever, so 10 to the power n, it moves n spots. Whatever that number is, that's the number of decimal places it moves. And basically, that's how we write a scientific number. So if we've got a really big number, we can write it as 1.23 times 10 to the 6 or something like that. So this part is always a number between 1 and 10, and times by some sort of power of 10, which tells you how many decimal places it has. So 1.23 times 10 to the 6 would be 1, 2, 3, and then the decimal place starts there, but it moves 6 spots. So it goes 1, 2, 3, 4, 5, 6, and finishes there. But then in between, we've just got all these zeros here. So the actual answer is 1,230,000, like that. And so that's a bit about scientific notation. Let's just also talk about what 10 to the negative 1 means. You may or may not know, but 10 to the negative 1 means 1 over 10. Another way we can write 1 over 10 is 0.1. 10 to the negative 2 is the same as 1 over 10 squared, or 1 over 100, or 1.01. And again, you just keep going on and on and on, and you get the same thing. 1 over 10 cubed, which is 1 over 1,000, equals 0.001. And it just keeps on going. 10 to the negative 4 is 0.0001, etc., etc. And so again, if you multiply some number, 1.23 times 10 to the negative 3 or something like that, what happens if you multiply 1.23 times these, 10 to the negative 3, this really small number? All it does is it moves the decimal place this way. Okay, so you'll end up getting something really small. So a bit messy there, so I'll just delete that because that's confusing. But in this particular example, what that negative 3 does is it moves the decimal place this way. So it moves it 1, 2, 3, jumps there, ends up there, and you'll just get zeros in between. So the actual number that this is equal to is 0.00123. And so you wouldn't have that, obviously, once you've made the change. But that's how scientific notation works. So really, really big numbers look like 1.2 times 10 to the 17 or something like that. So that would just have lots and lots of zeros after it. Or really, really small numbers will look like 1.23 times 10 to the negative 6 or something like that. That's where the decimal places move to 6 places that way. So it's a really efficient way of doing big and small numbers. So firstly, we need to know how to change a normal number, so a decimal number. How do we change that into scientific notation? Okay, so for an ordinary number, so let's just pick one. let's just say 832.16 or something like that. So what we want to do is firstly write this as a number between 1 and 10. Basically, you just want to have one number before the decimal place. In other words, what we want to do is we want to have this as 8.3216. What we've done is we've written this as a number between 1 and 10. And so you just put the decimal place after the first number. But what have we done here? We can't just write this. What have we done? To be able to make this equal to this, we need to multiply that by 100. It's actually moved 2 decimal places. We need to move the decimal place 2 spots to get this back to normal. So if we're moving it by 2 spots to the right, it'll be 10 squared. And so basically that's how you change between a number, a decimal number, and this here is in scientific notation. So just again, we've got 832, we want to write this first bit as a number between 1 and 10, so 8.3216, you leave all your digits there. But to get back to what we had there, we need to move the decimal place 2 spots to the right. So to the right is always what we're thinking about. Right is positive, okay? So because we want to move it 2 spots to the right, we need to have 10 squared. And if you think about it, that's right. It's 8.32 times by 100. That's what this is. Let's just do it. Another one of those. So let's go 1,392.3. Let's put that into scientific notation. So this is equal to, again, we want a number between 1 and 10. So we just write the first digit and then we write a decimal place and then everything else. 3293. And we write times by 10. And now let's think about how many decimal places we need to jump. So to get this back to 1329, we will jump 1, 2, 3 spots. We're jumping 3 spots to the right, so it will be times 10 to the 3. And so basically that's how we change from real number to scientific numbers. Let's just do some smaller numbers. Okay, so let's do 0.000192. Let's write that as in scientific notation. Again, what's your first number here? When we go through, your first number is 1, so it'll be 1.92. And now let's just figure how many spots it's moved. Now, to get this back to this, we need to move the decimal place how many spots. So currently it's here, 1.92, and we need to go back to the left this time. We're going 1, 2, 3, 4 spots to the left. Because it's to the left, it's actually a negative. Okay, so right is always positive. We've gone to the left, so we need to multiply this by, how many jumps was it? 4 jumps? Just let me check. 1, 2, 3, 4. We want 4 jumps to the left, which is negative 4. And the way that you can check that you've done this right is negative numbers should always be really small decimals. Okay, and here we've got a really small decimal. If you're getting positive indices, that's going to give you big numbers. Okay, so just again, let's do 0. Let's just do something. Yeah, no, that's okay. This will illustrate the thing very good. 0.001031. Okay, let's write that in scientific notation. Jump to a number between 1 and 10, so your first number is 1, and then just write everything after that, 1.031, and we want to get this number back to that. What happened? So at the moment we've got 1.031. How many spots do we need to get back to this? 1, 2, 3 jumps to the left, so left means negative 3, and that's how we convert that number to scientific notation. Can be a little bit confusing, but it just takes a bit of practice. Okay, so make sure you get that done. Now let's go the other way, and let's convert from scientific notation back to a normal sort of decimal. And this is probably a bit easier. Okay, so let's just have 8.26 times 10 to the 4 or something like that. Okay, so getting that back into a decimal, what do we do? Okay, so let's have a look at this. We've got 8.26. Now this 10 to the 4, that makes the decimal place go 4 spots to the right. Okay, so you're going to have 826, and your decimal place is going to start there, but it's going to jump 4 spots to the right. So 1, 2, 3, 4. It's going to finish there. And so you've got blank spots in between, which you just fill up with zeros. So your answer is 82,600. Great. Let's have a look at another one. 11. Oh, sorry, that's just, it can't be 11, but that's the number between 1 and 10. Let's just try that again. 7.2019 times 10 to the 7. Okay, so this should be a big number because you've got times 10 to the 7. It should be like, 10 to the 7 is like 10 million. So it should be about 70 million. So let's do that. We've got 72019. We're going to start with our decimal place here, but we're going to move 7 jumps. 1, 2, 3, 4, 5, 6, 7. And in your gaps, just leave zeros there, and that's your answer there. You're going to have 72,019,000. That's what that is equal to. Let's do some small ones. Let's do 1.932 times 10 to the negative 4. Okay, so again, if you've got negative numbers, it's going to be really, really small. So I'm just going to leave some space to the left. I'm going to write my 1932. I'm just going to leave some space to the left because I know I'm going to have to do jumps to the left for this one. You start with it at 1.932, and we're going to do 4 jumps to the left. Left is negative, so we go 1, 2, 3, 4. So that's going to be your decimal point there, and so you can have zeros in all of those gaps. And because you can't set 0.0, we'll have 0.000193 is your answer for that one. Okay, we'll do just one more. We'll do 8.001 times 10 to the negative 6. Again, we'll write our 8001. A decimal start there, and it's going to do 6 jumps to the left because of negative 6. 1, 2, 3, 4, 5, 6. And finish there. So I have 0.000008001. So hopefully that helps you with scientific notation. It's a little bit confusing in going between them. If you know your powers of 10, like I talked about before, with your 10 squares and 10, 10 negative 3, if you know those, it helps you to sort of be able to figure out what's going on if you get stuck. Hopefully that's okay. See you in class.